How's it going, everybody? Andrew Robinson here, back at it with another Max MSP tutorial. In this video, we are going to talk about a super incredibly useful set of objects, and those are the ZL objects. The ZL objects do a ton of different things, all around list processing, which is a very important part of Max MSP, especially as you try to build higher level, more complex things. So let's just jump right into it, shall we? First things first, we're going to look at this setup that I have right here. You may remember this from the last tutorial. This was what we did in the multi-slider tutorial, and as you can see, I have a multi-slider with 6 sliders going into an unpack object, unpacking each slider value. So as I change this, we can see what that value is here in the floating number box. Now, what I had mentioned in that video was that this could be an issue because we have it set to a fixed value of 6 integers, and that's it. We have 6 sliders, and because we're using this unpack, we have to define how many outlets we have for to unpack from this multi-slider list value, and we can't change that. I mean, I literally could change it by changing the size attribute, but you see, because, you know, unpacked has to take a specified amount of values to create the outlets for it, we're still only going to get the first 6. We're not getting these other ones here. And if you needed to create a, multi-slider that had changing slider values depending on what you're using it for, using this unpacked method isn't going to be that great because you're just stuck with these 6 values. Now, if we look over here, we have this object called zl.lookup. And basically what you do is you give it a list into this right inlet and an integer into the left inlet, and it's going to look up whatever that value is in that list. So here you see we have this 100 going into this prepend size, which means we now have 100 sliders in this multi-slider object. And if I just click this bang, which is going to send a random integer value into the zl.lookup, it sent the value 51. So our 51st slider is set to a value of 44.44. I click it again, I get another random value, whatever, 63 is 54.90, and I can change the size of this multi-slider down to, like, I don't know, 5 maybe, and now we will only get, those 5 values. It's still random because that's how I programmed it, but you could easily, send it an actual integer if you were trying to be more specific. And that is crazy because that is so different from how this is working over here. You could have a changing number of sliders and still get, a return value of any of them, no matter what, because of this setup. It's the same thing, sort of. It's just much more dynamic because you can change those values. So let's look at the ZL objects and everything they have to offer. If we right click on the zl.lookup object, or you just type in zl.something, and right click that, you're going to see this extra help option on the menu. If you click the ZL objects overview, it's going to open up this reference window with all the ZL objects and all the ways in which they do list processing. And we're just going to step through this one by one because they're all so valuable for so many different reasons. Like, it's worth talking about every single one of them. So let's just go through that, shall we? The first one we see here is zl.sort. And you see it says -1, which will change the direction of which this is sorting. We're going to open up the Max console real quick because you see it's connected to a print object, so it's going to print the output of the list processing from the zl.sort into this Max console. I'm going to click this message, and it is sorted beep bap 137 2.31. So that is in descending order, and you see it's doing it alphabetically and then numerically. If we get rid of this -1, if we just leave it blank, it'll do it in ascending order, which is what you might expect more if you were trying to use this. So now we see it says sorted 1, 2.13, 137, BAP B. And again, it's now numerical and alphabetical. It's just in an ascending order versus a descending order. And that's it. All you got to do one or the other is just set it to -1 or leave it blank. Super easy. ZLslice will slice the list depending on the value assigned to it. So it says 2 here. So after the second value, we're going to slice the list. And the one slice will be sent out the left outlet, and the other slice will be sent out the right outlet. So I'm going to click that, and you see we got the sliced message, and we got those first two values, beep and 1. And the 2.3, the 137, and the BAP were sent out of this outlet, but because it's not patched into anything, we can't actually see it. So I'm going to press M, create a message box real quick, patch that into the right inlet of the message box, and we're just going to change this number to, say, 3, so we get a different example. And I'm going to click the message again, and there you go. Now we sliced it at the third value, so 3 came out this outlet, and we can see those 3 values. It says beep, 1, 2.3, and the others that did not get sliced were the 137 and the BAP, which have come out of this outlet into this message box. And that is super, super useful. This next object here is zl.group. And this is set up in a pretty funny way. It says zl and then the number and then group. You could do zl.group and then the number. That's generally how I would write it. And all it's going to do is it's going to create a list based on the number assigned to it. So once this zl.group object receives 512 values, it's going to print out its list of those 512 values. So I'm going to click this bang, which is connected to this Uzi, which just sends out a lot of bangs. And in fact, it's going to send out 1,024 bangs. And we're going to get the index of those bangs out of this outlet. So it's going to just count up numerically. And I clicked it, and you can see it did that. So it started outputting 1, 2, 3, 4, 5, 6, 7, 8, 9, blah, 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 all the way up to about, 512, which is when it output that first list. And then it, continued to receive values. So when it got the second group of 512 values, it output that list. And we could see these two as two separate lists in our Max console. So zl.group is useful for a lot of different reasons too. If you're trying to create a collection of values and form them into a list, zl.group is the object to go with that. So that's super useful. And let's just keep moving right along, shall we? zl.change filters out the repetition of values. So you say, I have this list, A, B, E, C, E. I click it, sent it through, and you could see in our message console, it says A, B, E, C, E. So it didn't actually filter out that repetitive E. However, if I click this again, we're not getting any output. So that's the way in which it actually filters out repetitions. It's very similar to the regular change object. It received a list, and it's not going to output anything else as long as it continues to receive that list. It will only output once it receives a different list, like this list down here. So I click that, and now look, it outputted. And if I click this again, it's not going to output at all until, again, it receives a different list. So as long as we just go back and forth between these two, it'll work, but it can never send that same list twice in a row, which could be very, very useful for many different reasons as well. And getting this 1 or 0 out of this outlet on whether it has changed or not could also be a very useful feature for a lot of different reasons. zl.compare compares two lists. So we're going to click this ABC, and it went into the right inlet, and we're going to click this ABC, which is going to trigger it. And because these lists are the same, we got a 1 out of the left outlet, which means that, yes, these two lists are the exact same. Now, if we do ABCD and click the ABC list, it did not output that 1. Instead, it output a 0 because there is a difference between these two lists. And out of this right outlet where it says print indexes, we can see in the Max console the value 3, which means it is the third value in this list that did not match. And if you remember, we start from 0 with a lot of things in programming. So this first value is 0, 1, 2, 3, and yes, in fact, it is that D from this list that did not match in our input list over here. So it is that third value that is different. If we added like an E to this and click that message box and then click this message box, you see it now says 34 because it's this third value and this fourth value that are different from our input list. If we click the ABCD, now it's only that fourth value that's different because that first list doesn't have that E. So yeah, super useful, especially since it tells you which value is the incorrect value. That could be useful for a lot of different reasons. Let's look at zl.delace. So basically, it's just going to alternate separating them out into two separate lists. And we have this A1, B2, E2, C5.5. If we click that message, you can see out of this outlet, we got the ABC, ABECE. And out of this outlet, we got the 1, 2, to 5.57. So that's pretty cool. It just separated each list out. This one went here, and that value went there, and there, and there, and then out that way, and it just basically alternates sending them out like that. Same thing if we click this message. The 10 went out this way, the 20.1 went out that way, then the 30 went that way, and then the 40 went out that way. Which, yeah, super, super useful if you're trying to separate a list. Another way we could separate the list is using this ecils object, zl.ecils, which is actually just slice spelled backwards. And that's because it is the exact same as slice, except it just does it in a reverse order. So we have 1 here, and if we click this message, you'll see it sliced off that last value of the list, which is the first of, the reverse order. And it printed that out, that outlet, and the rest, the 1, 2, 3, 4, 5, went out that one because we didn't care about those slices. So yeah, same thing as slice, just it works in reverse order. ZL.filter removes items from a list. So you see in the ZL.filter, we have Toto and TT set already. So if I click this message that has Toto and TT in it, you'll see out of this outlet and sent to the print filter, we got the ABC1, which is everything that was in that list, but with Toto and TT filtered out. And then you see in the filter indexes, it also specifies which were the values that went through. So we had that 0 that went through, this 1 that went through. We didn't send the second value Toto, that one was filtered out. So no, there's no 2 in that list, but the C didn't make it through, so we get the 3. TT didn't go through, so we didn't get that 4, but the 1 went through, so we got the 5. And that's super useful, both for, filtering out and removing duplicates, and then also if you need that index value. Down here is a zl.group, which we kind of already looked up at here, but this is just a different example of it. You see the zl.group is only set to 4, so we can send, a random values, and if we sent 4 values, which we just did, it saw that it had collected 4 values and then output that list of 4. And you can, do this anyway. I sent a 1, 2, 3, and then a 5, so then it output the next list of 4, 1, 2, 3, 5. Super, super cool, super useful. If you did, need less than the values you defined, you can just send it a bang, which is super useful. This is, ZL group 4, so it's expecting a group of 4 incoming values. But if we only sent it 2 and then press bang, you see we get the output of just those 2 values, the 6 and the 7. So, if you needed to, you could always have it output before the group has completely filled up, which is, again, a actually very super useful feature. I do that all the time for certain things. Let's click on this tab and keep moving right along, because you see there's still so many more ZL objects to talk about, and each one still doing something super important and useful. ZL.indexmap is great if you need to recreate a list from specific values. All you got to do is send it said index map into the right inlet. So we're going to send this 4, 3, 2, 1, 0, 1, 2, 3, 4. And then we're going to send it a list into the left inlet. And it's going to create a new list mapped like this. So it's going to see whatever the 4th value is in this list, which in our case is E, because again, this starts from 0, so it's 0, 1, 2, 3, 4, and it put that E as the first one, and then it looked for the 3rd, which is the D, and then the 2nd, which is the C, B was the 1, A was the 0, and then we started going back up. So that's why over in our max console, we have it descending and then ascending. It's the same as this. It's just replacing the integer values with said value of the list, whatever that list may be. So that's super, super useful if you need to, create new lists from already existing lists. zl.iter is very similar to zl.slice in that it will slice the list at the integer value you've defined. The only difference is it's not going to output the slice through the left inlet and then the rest through the right inlet. It's going to keep slicing it and output all of those through the left inlet. So let's just show that. I'm going to click this message box, and we took a slice of the 3 here, which is the first 3, the 5, 6, 7, and that printed as a group. And then immediately after, we had the next slice, and then there was one left over, so it just printed that one by itself. This is super useful for a lot of different reasons too. But don't be confused. If you said, if you attached a message box to this and you clicked that, you're only going to see that 11 because that was the last thing output. But we know we actually slice this up in sections of 3 because we can see that in the max console, and that picked up everything. This is only going to display the last output. So don't let that confuse you. It is slicing in groups of 3. So super useful. Very valuable tool and can do a lot with that. Let's look at zl.join now, which combines 2 lists. And all it's going to do is stick them together. So if we click this 1, 2, 3, and then this 3, 4, 5, you can see that's not joined to anything. But if we click Bob, Joe, Frank, and then 1, 2, 3, 4, you could see it stuck that left list into the right list. And it goes 1, 2, 3, 4, Bob, Joe, Frank. And that's it. It just stuck them together, just like that. ZLlace is similar. It's a great way to combine 2 lists, but it's going to alternate them like we saw with the delace. So if we click this and then click this, you see now we've created a new list where these 2 things are laced together, and it just alternates. It's now 1A, B2, E2, C5.5, E7, and you see that's just the A1, B2, E2, C 5.5, so on and so on. These extra values got ignored, probably because there's no way to lace them in. So that is an important thing to pay attention to when using this object. ZLlen tells you the length of the list, which again, super easy, but super valuable if you need to know the list of the size of your list, if that's something that changes a lot. So I sent it this message, which has 3 values in it, so it told us that message was 3. This also has 3 words in it, so again it's 3, but we could add something extra like a question mark, and look, now it's 4 because there are 4 values in that list. So super useful, super straightforward. zl.lookup is super useful, and we saw that actually here in this example, and it's so easy. All you got to do is, like I said, you send it a list into this right inlet. So right now by default that list is set to toto tt22, and if you just send it an integer value in the right inlet, it's going to pull up whatever value is stored at that position in that list. So I sent it a 1, and it says it's 0 base, so we go 0, 1, and that was the TT, which is printed to the console. So that works, and we could switch out that list if we click this message, AB14, and then same thing, I'm going to send it a 2, and it output that 1 because that, again, starts at 0, so 0, 1, 2, that's the 1, and it printed that to the console. So perfect, that works out. zl.median finds the middle number of your list. So if we sent it this, the middle number of that list is 5.5. If we sent it 613, it's 3. And if you look at this, you might be like, wait, isn't it supposed to be 1? No. Mathematically speaking, 3 is the middle. So it's going to sort this list whenever you send it into the correct order internally, and then output the middle value of that, which, if this was sorted in the right order, it would be 1, 3, 6, and then 3 is that middle value. So don't let that confuse you. But that is also pretty straightforward. It's just outputting the median value of the list. ZLmf, which is a funny name, but a super useful object. It's very similar to zl.lookup. It's just the inlets are essentially flipped. Rather than sending a list of values into the right inlet and an integer into the left, you're going to send the integer into the right and the list into the left. So if you see it set to 3, I'm going to turn that back to 3, send it the list, and then we get the third value, which is 14. And that is correct because it says this one is 0 base. So 0 is the 11, 1 is 12, 2 is 13, and 3 is that 14. So yes, we got that 14 return. We can see that in the console. Super useful if this is set to something that isn't in the list values, because we set it to 12, but there isn't a 12th value in this list. It's going to print all the remaining things out of the other outlet. So that could be useful for a lot of reasons as well. Moving right along, we also have ZLmf, which is exactly like ZLmf, except it's 1 based. So rather than being 0, 1, 2, 3, 4, it's going to be 1, 2, 3, 4. So the first value is a 1, and that would be this 11. Don't let that confuse you. It's just whether you're counting 0 as a value or not. This may make more sense to people just intuitively because we don't generally tend to think of 0 as a countable value, but a lot of programming stuff does count 0 as a countable value. And so it's nice to have the option to either include or not include that 0. But again, these work the same way. The integer is sent into the right inlet, and then it's going to look for that value in that list and print it out. So it's by default set to 3 already. And if we send it the list into that left inlet, it's going to count 1, 2, 3 and pull that third one, which is 13. And we see that in the console. You can do more with the zl.nth message as object as well. Which is super useful. For nth mode, an extra argument in the right input will be used to replace the nth element. So you can replace values in a list with this object as well. Super useful. And if we look at this message here, it's $1, so that's our variable, and then a value. So if we just set something in it like 2, it's going to replace this second value with this value. So it's going to look at this list. It's going to say 6 is in that second spot. I'm going to now substitute that 6 with this 0.5. And if we click the list to send it through, you'll see that that worked. It is now 5, 0.5 instead of 6, 7, 8, 9, 10, 11. And we still got that 6 out of this outlet, which is nice and useful. And it's also useful that we can replace it. And it doesn't have to be replaced with integer. If we sent this to high, it's going to replace that second integer value with the message hi, which is super cool. zl.queue, also a very, very useful object. It's first in, first out message storing. So if you click this 3.14, that is now stored in our queue, and we get out of this right outlet the size. So the size of our queue is now 1 because we've just sent one thing in it. And if we click beep, that is now stored behind the 3.14, and we see our size is 2. And then we can send some values like 1, 2, 3, and our size continues to increase, and everything is being stored in the first in, first out order. So because 3.14 was the first thing we clicked, when we send this a bang, we're going to get that 3.14 back first. And you see it also says our size decreased to 4. So that's super useful that it gives us that information as well. If we send it another bang, we're going to get the next thing that went into it, which was the beep. And again, we see that printed to the console and our size decreased. Send another bang, so on, so forth. We got the value 1 that we stored in after the beep, and we see our size now 2. Now we got the 2, and we have a size of 1, which means there's one thing left in there. So again, we're going to click that, and that last thing was our 3 we set in, and now our size is 0. And if we send a bang to this, nothing is going to output anymore because nothing is stored in the queue anymore. We could send another thing, beep, and then 3.14. Our size is back to 2. We send the bang, we get the beep, and then we get the 3.14. So whatever order goes into the ZL queue, it's going to come back out that order once it receives a bang. So that's super useful if you're trying to build a list of, actions to occur in a certain order, but you don't want them to occur right away or something. You could use this to make those actions trigger at a later time or something. A lot of different features that could be useful for. zl.reg stores a list in the right inlet and bangs it out later. And it now takes int. So we can send it an integer of 5, 6, 7, and that list is now stored in here, and we can click that bang whenever we want, and it output that list of 5, 6, 7. Yeah. And if we, sent it a different list like ER56, we can click that bang, and then that got stored out later. So that's nice. That's a useful feature. I'm not going to lie. This is the one I probably use the least, although I have seen it used in some instances. But to me, this isn't any different than a message box. A message box can store a list and send it out later. So, this is the only one I would say, yeah, I'm not sure what the value of it is, but it's there and we can use it. And if it makes more sense to you to use that than a message box, I say go for it. You'll probably find a reason why that would be more valuable. zl.rev reverses a list. So we have this list 1, 2, 3, 4, 5, 6, 7, 8, 9. And if we click it, you see it gets reversed into 987654321. So, super straightforward. Just reverses the order of the list. zl.rot rotates a list by a certain number of places. So it says 3 here, which means we're going to rotate it by 3 places. And this is tricky because it will get rotated right and wrap back around from the left side. So if we click this message, you see 3 is now first in the list because it went over 1, 2, wrapped back around to the first spot, which would be 3. And therefore, it's now the first in the list. So you got to remember, it's going to rotate it right to left. Unless you, of course, send it a negative value, like -3, in which case it will then rotate left to right. And so that moves the 5 into the first position because it goes 5, goes over 1, 2, 3, right there. So that's very important to keep in mind, that the value you send, whether it's positive or negative, will affect the direction it is rotating. ZLscramble is fun because it just randomly reorders a list. If we send it the 1, 2, 3.4, Toto, TT, 22, you see we got 221 TT 3.Toto2 back, and if we click it again, it just continues to randomize it. And it's cool. It's just going to randomize your list. That could be fun for a lot of different things. Super useful also is it tells you the indexed order that it randomizes it to. So the first time we clicked it, it went 5, 0, 4, 2, 3, 1. The next time it was 1, 4, 5, 3, 2, 0. That could be useful, if you're trying to keep track of the way in which the ZL scramble is scrambling your list. That could be useful for a lot of different reasons as well. Always useful to just know the index values. So it's really cool that all these ZL objects return that to us. ZLsect looks for what's in common between 2 lists. So if we click DEF and then click DDD, you see that D is in common. There's a D in both lists. If we click BCF and then DDD, nothing prints out except for this bang out of this outlet, which tells us that nothing was in common, because we'll only get a bang out of that outlet if nothing is in common. So there's no D in this BCF list, therefore nothing's happening. But if I click the ABC, you see we get B and C out of the left outlet because there's a B and a C in this list. Pretty useful and pretty straightforward as well. ZLslice we already looked at. It separates a list into 2. So we'll just skip past that because we already looked at that one. This is the first thing we looked at. ZLstack is very similar to zl.queue, except it's last in, first out. So it'll output the last thing that comes in before outputting the first thing that comes in. So we send beep first and then 3.14. Our size is 2, but if we send a bang, we got that 3.14 first, and then click the bang again, now we get the beep. So yeah, same thing as zl.queue, it's just doing it in the reverse order. ZLstream makes a list with the last n items. N is the value that is being defined here in the object, so this says 5, so it will make a list of the last 5 items, and I'm just going to slowly increase this, and you see it made a list of the last 5 items, which was 1, 2, 3, 4, 5. If you put a negative, it's going to do it in descending order. So again, super valuable, just depending on what you're trying to do. Now, here's the difference. If I send it 6, bam, we already got the output because it's the last amount of items. So it's going to update it. It's similar to zl.group, except it's just not going to wait for an entire group of values before outputting. It's going to output as soon as, it gets whatever value it gets. So that's super useful. And if you did, there's the zl.clear object. You could restart the list. And now I'm sending it and nothing's outputting it because it's going to wait till it at least gets 5 values. So super useful and very similar to zl.group, but just slightly different, and you could use either depending on the context that you need. ZLsub outputs position for each occurrence of the right list in the left. So if we click something like 7, 8, 9, and then we click this message, you'll see it found 1, 7, 8, 9 at the 7th position of the list. And you see right there in this list, there is a 7, 8, 9. And if we counted 0, 1, 2, 3, 4, 5, 6, 7, it would be at the 7th position. Which is super cool and super useful, and also very important to note that it found the entire grouping of numbers. It didn't look for 7, 8, 9 individually. It looked for that together as an occurrence. If we switch this 9 to a 10, and clicked it, and then click this message, you see it says found 0 because it doesn't go 7, 8, 10 in this list. So you have to be very specific about that. It's going to look for the list grouping, not each individual value. Important to remember. ZLsum sums the list together. So super straightforward as well. We click this, and all these values added together is equal to 43.5. Same thing, if we click this list, all these values added together is equal to 10. Pretty easy. ZLswap will swap two list values at whatever index they are at, and remember it says it's 0 base, so if we send this 0, 2, it's going to swap this one because this is our 0 element, and then 1, 2, it's going to swap this one as well. So well, instead of being A, B, C, D, E, it's going to be C, B, A, D, E, and if we look at the max console, yep, it switched the C and the A. And if we click 1.3 or 1 and 3, it's going to switch the first and the third, which is the B and the D. And yep, we can see that in fact got swapped. So super useful. You're just sending it the index position of what value is in the list and where you want to swap it with. Super easy. zl.thin removes duplicates from a list. So you would think that that's what zl.change does, but that is not what zl.change does. zl.change was looking for the repetition of the list as a whole, and this is looking internally into the list. So if we click this message that says A, B, E, C, E, B, B, we're going to get a return of just A, B, E, C because it thinned out all of those duplicates. So there were no more B's, no more E's. We just got what was in there, just like that, thinned out. Super cool. So zl.union is going to join these two lists together, but it will not duplicate repetitive values. So if we send this 6.5 for 2.3228 and then this 2.37 6.5, you'll see we have now joined these lists together but without those duplicates. So it goes 2.3 from this list, then 7, and then 6.5, and then the next value is 4 because this 6.5 and this 6.5 are the same, so it ignored those and just went to the 4. And then we had a 2.3 here in this list, so it's ignoring this 2.3 here. And then the next value was the 2, so it added that to the list. But then, you know, we got another duplicate 2 in the same list. Doesn't matter, it filtered it out. And then all that was left was the 8. So it basically joins the two lists and then thins them for duplicates. Very valuable and combines, you know, a few of these ZL steps into one. So that's super useful if you need to do that. ZLunique makes a list of items in the left input that are not in the right input. So let's look at that. Let's click tata tt and then toto tt tutu. And we see we now have a list that is toto and tutu. So it saw that there was a tt in this list and it ignored that. It filtered it out. There could have, if there was a tata, it would have filtered that one out too, but there wasn't, so it just didn't get added into the list anyways. Same thing here. If we click this 4791 and then this 1359, we only have a list now of 3 and 5 because the 1 and 9 in this list were now removed. So again, super useful depending totally on entirely your situation, but all of these objects I use them all the time, and they're so incredibly useful for dealing with lists because so much stuff in Max is a list. As we just saw, you know, in this straightforward example, it's much easier to do this than it is to do this. And this allows you to do so much more as well because you can dynamically change the size of the multi-sliders and still get a return of any one of those values. Here, you can't do that because you'd have to change the code of the unpack object to tell it to look for like 100 sliders, and that's going to give you 100 outlets, and then you're going to have to patch those outlets into things. So that's not very useful because that doesn't allow, you know, a whole lot of dynamic change in the patch itself. So that's why it's very, very important that we kind of go over all of those ZL objects and understand what each one does, because each one is very valuable totally on certain use cases, but they really let you expand out and just program at such a higher level because you can, you know, do so much more with lists if you understand how these ZL objects work. So I hope that made those objects very clear. And, you know, now as we move forward into more advanced stuff, we'll probably start to see a lot of those pop up time and time again in a lot of future tutorial videos. But that's going to be it for this one. I hope you guys learned something. If you did learn something, please let me know by liking and subscribing, because that's really just the best way for me to know that I'm doing a good job. If there are any questions left over, please leave those in the comments down below, and I will see you guys in the next video. Thanks so much for watching.